Okay, good morning. So I come from a company called Raute, or Raute in Finland, and from a unit Mecano business. Raute is quite an old company, I would say. We've been here more than 100 years, but Mecano is slightly younger. However, the thing is, what we do is we supply machinery for plywood and any veneer-based industry. Raute is the only company in the world, and I can say this proudly, that can deliver machinery to a whole plywood or LVL mill in the world. And we are also the only manufacturer on this business that operates on all of the continents except the Antarctica, which is kind of small on plywood. But other than that, we provide a working place for approximately 650 people in different places of the world. We have the headquarters in Nastola, and this Mecano business unit is located in Kajaani. Mecano comes from a company called Mecano Group Oy, which was established early 90s and operated as a own company until 2000 or something, and 2008 Raute acquired and merged us into the company. But we still consider us as a separate unit, and in that sense we can call that the Mecano spirit, and also the remote location of Kajaani keeps us somewhat as a one team. Nowadays we have 36 people and one guy in Vancouver, BC, taking care of the North America. We do measurement devices for this industry, mainly machine vision applications, but also moisture analysis, density analysis, and strength analysis now to the veneer-based business. We do most of our research in-house, but my responsibility, or one of those, is actually taking care of the cooperation with the universities and measurement labs and different kind of research entities. We've been doing traditionally quite a lot these kind of new stuff development with the universities and entities like that. Here's some locations that we reside. We have headquarters, like I said, in Nastola, Finland, as well as our main production facilities reside there. We also have workshops in Vancouver, BC, as well as in Shanghai. So we can easily provide machinery to all around the world because of these three locations. The other thing is that we have main offices in 3 major different time zones. That also helps us to support our customers in whatever the time of the day is. We have companies and agents in all of the major plywood producing companies, countries, and the one I'd like to throw out here in St. Petersburg, we have also a unit supporting the Russian market. So I prepared my presentation earlier last week, and it had almost 100 slides, so I decided to cut them a bit. There's a limited time. And instead, they say that one word or one picture says more than 1,000 words, but I can say that you can mesmerize 1,000 people with one video. So let's see how it goes. This is to give an introduction. It's a commercial video, but to give an introduction to plywood manufacturing.
After serving the world for over 30 years, the space shuttle turned its come to a final stop.
We copy your world stop, and we'll take this opportunity to congratulate you, Atlanta.
Best wishes. After serving the world for over 30 years, the space shuttle turned its come to a final stop.
We copy your world stop, and we'll take this opportunity to congratulate you, Atlanta.
Best wishes.
Okay. So as you see, there are quite many different process stages in making plywood. First you have to take the log, condition that, then you take and peel it out, clip it into sheets. Some of the sheets are patched, some of the sheets are composed, some of the sheets are scarfed to get the utilized all of the raw material. And then you apply glue, lay it up, press it, do the side trimming, maybe sand it, and then you have the panels that you can ship out. Raute does not make plywood, I have to say it. We make machinery for making plywood, as well as the applications for making it easier and profitable today. And the Mecano business unit, we just released our G5 platform, which is actually more than just machine vision applications. It's a whole digital services and all kind of umbrella that everything goes underneath. But here I'd like to pinpoint some of the applications. As the title of the today's presentation was something about photonics, I tried to keep it as camera applications. So we have this is our standard VDA frame, as we call it. VDA comes from Visual Defect Analyzer. We have a industrial frame painted with McLaren gray metallic paint. We have a camera or multiple cameras up here located in a highly pressured cabinet so that any dust doesn't go in and it stays clean. Then we do have most of our analysis equipment installed into this kind of a cabinet, which is also refrigerated so that it can handle different kind of temperatures. We do have our own design illumination based on LED technology, top and bottom lights, and we also control those with our own designed light controller, which is fairly important when you start thinking about the actual imaging. And then we have nowadays freely locatable operator panels that you can throw out wherever in the mill, as long as they are network connected. In some of the analyzers we do provide moisture analysis integrated. It can be also X-ray or density or microwave-based moisture analysis. And this unit provides some data that helps the customer to do things whatever he wants, whether it's being optimized clipping or just sheet grading. The machine vision itself is actually set to a bit of a side. It's just a tool, but it's not the actual application. And that's a quite important thing, that you understand the way your customer is doing his job and what he needs, and he's not interested in pixels and intensities or polarization or anything like that, but he's interested in how he can guide different kind of process flows to the exact right place where he needs in his process. So also one big challenge for us is to understand the customer and make the user interfaces in such a way that they can be used efficiently. Maybe one of the most important applications is value clipping, right in the beginning of the process, where a log has been peeled out as a ribbon, and then you run it through the camera. Camera decides what kind of, and locates what kind of defects there are, and then makes a clipping decision. We clip the sheet into a certain kind of width. We can also do the density analysis with X-ray and moisture analysis with microwave based analyzers, and then also define accurately how wide you want to clip the sheet, so that after it's been dried, it dries into the correct width, and you save raw material. So, like I said, it's not only machine vision, but it's a combination of all of these intelligent sensors. Then there are different scenarios depending on the customer, depending on the country, depending on the process, tree species. You cannot say that there is only one correct way of clipping veneer. It actually depends, even within the same company, it may differ from mill to mill or line to line. So we need to have multiple different strategies inside our application that the customer can easily apply and control. And here's just one simple example of a veneer ribbon. You identify certain kind of defects, and you decide when there's enough good raw material that it can be used for composing, which means, I'll show a slide later, combining good pieces of veneer and then upgrading that material. And when do we have enough good material that we can start clipping full sheets for face, for example, face veneer. Then grading and sorting, usually this happens after the sheet has been dried. So we, on a green sheet or wet sheet, we're talking about moisture contents between 30% to even 250% water out of the dry mass. And then after drying, it's usually around 6 or 7%. In some cases 15, some cases 4, again, depends on the customer and the tree species. But this is the first point where you actually divide these process flows so that which piece of sheet goes to which part of the process. And if you do that accurately, then there's a huge kind of recovery available. Because on the other hand, if you don't do that, then you will have different kind of problems, process errors. In later processes, you need to take those sheets back to the right place, and that all consumes capacity and whatnot. So here we do visual analysis with the multiple different imaging methods. We do also usually density and moisture analysis with our moisture analyzers, and all this is integrated together so that actually the moisture map appears as an image layer in our G5 platform now. So you can apply similar kind of tools as you apply for images to the moisture maps. Composing and scarfing, these are usually slightly easier applications. In some cases, you only need to know where the sheet resides, in what kind of position, what is the size of the sheet, what are the edges, are there any big voids or open holes inside the sheet. And in some cases you need to be actually really precise, especially on the composing cases where you combine these pieces of sheet into one single good full sheet. You need to be able to detect these clippable defects. One very challenging comes a thinning or a certain kind of vein that usually doesn't have any kind of color contrast, but with a certain kind of imaging that can be extracted and detected and measured accurately. So you need to have good performance in this kind of a simple application also, in some cases. Then one example of this fairly conventional business that plywood making is. This kind of a pen marking is still used in, I don't know, maybe 80–90% of the mills in the world. And you consider tired operator that is thinking about the coming weekend or something else. It's really easy to make 2.5 centimeter error here, which is usually actually 5 or 10 centimeters. And when you can get rid of this by applying accurate machine vision based analysis and then clip it exactly on the known margin, we're talking about huge savings on the raw material. So just the one example. We've been really lucky with the actual, we call it VCO, Visual Clipping Optimizer, based on the same hardware platform as all of our camera graders. But we've been very, very lucky with our customers on this product, and it's actually been getting into the business within the last 2–3 years. Patching. You can actually take defects out of the veneer sheet. You punch a hole with a known size, and then you apply nice clean patch on it. Like here, we call this boat patch. And this has been actually a product that was developed in Kajaani, late 90s, or something like that. And nowadays, the maintenance, or let's say the further development of this product is carried out in Nastala. And we're talking about already a 2nd generation Patchman 2 that does this thing, but the machine cannot act without a camera and without reliable and accurate camera. So we need to be able to detect and classify the defects, where they are, what is the size, is it possible to be covered with a patch, or maybe if I use multiple patches in a different orientation, is it possible to cover that defect? Am I allowed to patch that defect? I need to be really accurate on the defect type recognition or classification, as we call it. And then even more and more important nowadays is we have multiple amount of patching heads. You need to be able to optimize the routes of patching, as well as the utilization of different robots. So there's quite a lot optimization going on the background just to get the defect out and put the patch in. We can also find defects that need to be taped, and we can apply automatically with a tape robot these tapes, and this way actually recover a lot of raw material. This is not really a structural defect in a veneer panel, ready-made veneer panel. It's not that big of a deal if there's this kind of a split, but the thing is that this kind of sheet is not going to survive through all of those process stages. In the end, or somewhere in between, it will break, cause a havoc there, stop the line, you lose capacity, and so on. So it makes sense to identify that kind of defects, put a small tape on that, on top of that, and this way recover the whole sheet for the rest of the process. 5 minutes. I'd say some of the final and most demanding applications are the panel repairing application, where you have to be really accurate on the 3D detection of the surface, as well as 2D, as we call it, the color defects, and then be able to control those robots that fill out different kind of defects on panels. But into the photonics. Like I said, there's a lot of more that we do, but I try to keep it simple here. We do use RGB imaging, but we also nowadays use F imaging, which is basically certain kind of high intensity light shot through the wood and helps us to identify different kind of thinnings, for example, anomalies on the grain pattern, micro cracks, obviously open voids, vein, different kind of thinnings there, and also gives kind of a fingerprint of the wood. Then we have the S imaging, which is a 3D estimation of the surface, roughness, different kind of waves, and holes even. Use a little bit manipulation, and it becomes more visible out of the original raw signal. But also, we can see some hidden defects nowadays with the F imaging. If I flip these around, you can see that there is actually more, for example here, inside, that you can see from the color image. And this is important, especially on the furniture grade kind of a birch or something like that, where you have to stain the wood, for example, or sand it. And it may look nice, but when you apply stain, suddenly these defects pop out. Detection of the defects or extraction of the defects is important. You need to be accurate and whatnot. And here's just an example how and what kind of things we can calculate and measure out of the defects. One example of utilization of these kind of color imaging and control automation is the panel repairing, where you apply certain kind of putty or filler into the panel. We can measure the approximate color of the panel and then, according to that, select a proper color for filler. And there has to be always something to brag about. And and today we're very proud. We've delivered over 500 different installations all over the world. And what we are especially proud about is the amount of different tree species. There is maybe a handful of competitors in the world that do machine vision for plywood industry, but usually they are concentrated on certain softwood or certain kind of tree species only. And we, because of our development on our own defect recognition library, we are able to support all different kind of tree species. It's also, in my mind, kind of a benchmark of the overall performance of the system. I'd like to tell a lot more, but you guys go to routesmartmill.com and see what is the latest happening on the plywood side. We are actually thinking that we are about to change this world within the next 2 years with this G5 platform, and it's a lot more than only just a machine vision application. And now, if there are any questions, I'd be happy to try to cover them. Thank you.
Thank you, Jyrki. That was fascinating. Any questions?
You have a lot of optimization. What type of optimization are you
So the question was about optimization methods.
Okay, fuzzy. Value-based. You can give a value for certain raw material, for example, and then you just apply it to different scenarios and calculate what is the optimum value that you get, and then clip it out. Then, as an optimization, you could also understand that you try to put as many defects into the products as possible without risking the final product. So in that sense, we have a lot of different methods where you can estimate, for example, a defect quantity on a certain area, for example, and then set up a rule based on that. Moisture optimization, which is not photonics, but it is an optimization. You can set up different kind of moisture strategies for different kind of visual grades, so that for certain grades you actually apply more moisture, and then you save the energy and capacity by putting the moisture into the final product instead of trying to get it aggressively out of the raw material. And then the optimization between different process stages. What kind of process flows you are guiding to which part of the process, and that's actually a big thing that this G5 platform enables.
More questions?
Yes.
How do you measure density?
So the question was how you
we
measure density.
We measure density two different ways. On a Greenland line, like said, where the moisture is like 32 to 150%, we use X-ray and the attenuation of the radiation. Then on the dry side, let's say if we stay under 10% moisture content, we use microwave resonance.
More questions? How much of the work is done using software and how much is done using hardware?
I'd say most of it is software.
Yeah.
The hardware is something you can buy from a local kiosk almost.
Yeah.
We use more or less standard PCs with some industrial theme on them. Cameras, you can go and buy them from manufacturers, but I'd say, and the machine vision part of it, it's an essential, but it's not the key to the final application. The final application is how to serve your customer, and that's more or less all about software and some visual appearance and things like that.
Yeah.
So I would say 80% software.
Okay. A lot. Any more questions? If not, thank you, Jyrki.
Thank you.
And the next